Welcome to qnawire.
Consider the graph of f of x below. Let's say g of x is equal to the integral from 0 to x of f of t dt, and we want to estimate the value of g when x is 35. Now, our g of 35, this is simply the integral from 0 to 35 of f of t dt. So based on this graph, it will just be the area of the region bounded by f of t and the x-axis. So looking at the graph, we need to separate this into several integrals. That'll be one for this, and then one integral for this, and then another integral over this part, and then another one for this part. So there should be 4 integrals. So the first one will be the integral from 0 to 5 of f of t dt, plus we have the integral from 5 to 15 of f of t dt, plus we have the integral from 15 to 30 of f of t dt, and then lastly we have the integral from 30 to 35 of f of t dt. So looking at the area over the interval 0 to 5, that's a right triangle, so that's half base times height. That'll be 1/2 base is 5, height is 5, plus we have in the interval 5 to 15, that's a triangle below the x-axis. So the area for that will be 1/2 times base, which is 10, times the height, which is -5. And then plus for f of t over the interval 15 to 30, that's still a right triangle. So we have 1/2 base is 15, and the height will be 15 as well. And then lastly we have, okay, this area here is just 2/3 of the area of the rectangle. So that'll be 2/3 of length times width. In this case, the length is 15, the width is 5. So adding these, we will get a value equal to 150. Okay, next we want to find the maximum and minimum values of g of x. To find the maximum or minimum values of g, we first want to find the derivative of g. That'll be the derivative with respect to x of the integral from 0 to x of f of t dt. And by fundamental theorem of calculus, we have g prime of x equal to f of x. So we want to set this to 0. We have 0 equals f of x, and these are the values of x, where the y value is 0, and that will be this x value, and this x value. So that'll be x equal to 5, 15, and then the other one is 35. Next, we want to use second derivative test. Note, by the way, that these are our critical points. Now, applying second derivative test, the first step will be to get the second derivative of g. So g double prime of x, that's equal to f prime of x. And at the critical points, we have g double prime of 5. This is equal to f prime of 5. And based on the graph, the f prime is the slope of the line. Passing through x equals 5, that'll be negative, so this is less than 0. And g double prime of 15, that will be f prime of 15, and this is greater than 0 since the function is increasing there. And then lastly, we have g double prime of 35. this is equal to f prime of 35, and this is less than 0, since the function is decreasing at this point. So when the second derivative is negative, this implies that we have a maximum at the critical point, which in this case is x equals 5. And the value here of g will be the area of the right triangle found in this interval, 0 to 5. That'll be 1/2 5 times 5, that's 25/2. And then for x equals 15, this is a minimum since the second derivative is greater than 0. So g minimum at x equals 15, and minimum value will be, well, this is going to be the area from x equals 0 to x equals 15. So over this side and this side will cancel out because they're the same in area, but the other one is negative. So that cancels out, and we're left with this area, which is just the area of the triangle. That's 1/2 base times height. The base is 5, the height is also 5. So that's negative 25/2. And then lastly, we have at 35. This is a maximum. And the value will be, that was found in part A, that's 150.